Okay. Thank you for your patience. So this new unit is completely different. There's no trig, but well, we may infuse some trig, but we might infuse some exponential, we might infuse some logarithmic, but at the heart, it is just a completely separate topic. And I think you're going to enjoy this change of pace here. Hopefully, we're talking about sequences, theories, and the last thing we're going to learn is counting, which is harder than you may think. But I talk about counting, you know what I'm talking about? One, two, yes, etc. Yeah, nice. So you studied ahead. Okay, I like that. Thank you. Okay, you can see that there are some quizzes for our class. We're gonna have one quiz, March 5th. I believe that's Tuesday, and I believe that we have our class day on days 1, 2, and 3. So whatever we do today, next time, the day after that. Our test is Tuesday, March 19th. When is the first day of spring break?
23rd?
It is that the last week before?
Yeah. I think so.
Okay, so that Friday is our last day of school. It's nice to have it a little bit before break. Second.
No. I think it's the last one, because we have like the last week of March and the third week.
Yeah, but March.
I think that this does it.
March 9th is not.
March 9th. March.
Yeah, March 9th. That was the last week. That Friday was March 9th.
Check my calendar.
We're talking about the.
That's what I'm talking about. That's what I'm.
Make sure. Yeah, the 22nd we have school. That's a Friday. The 25th we're on break. So that's that's the last week before break. Okay, well let's get to it, shall we? Pretty intuitive unit. Things can get complicated with notation. But we're going to begin with sequences, and you already know the word sequence, right? It's when something happens in sequence, that means that there's some sort of an order that's going on. And so when we talk about a sequence, it just means a list. In a math, it means a list of numbers. Sometimes those numbers will be represented algebraically, or sometimes it's just represented randomly, or let's see what this looks like. So some notation that you're going to need to know is, first of all, the first term in the series is often referred to as a sub 1. The second term, a sub 2. Third, a sub 3, etc., etc., etc. Oh wait, this one's blank. What would this one be? This first blank one would be a sub 0. Do you have any idea what that might be?
Between 11 and 9.
9?
What are you talking?
A sub 9, would that be right?
No ellipses in there.
Of course it's a sub 9. That's just the 9th term, because we know that because the next one is a sub 10. And the one after that, a sub 11. That just means which number in the sequence we're dealing with. Those numbers could be anything, but the 11th term in the sequence is called a sub 11. The 4th term is called a sub 4. But wait, there's more. Could you go ahead and fill the rest of these in? One of them has something. I don't know what the next ones would be. Check with your neighbor. Let's do this one first. What do we call this? Yeah, fine.
A sub n minus 1.
Does that make sense to be a sub n minus 1? And you knew that because
Because it's one less than n.
speaks the truth. Did you get the one before that?
A sub n minus 3.
Are we good, everybody? Of course, after a sub n, the next one would be a sub n plus 1, then a sub n plus 2. We'll be talking about those today. After that, a sub n plus 3, a sub n plus 4. Now, n could be any number. It could be 100. And if this is a sub 100, it works out that this is a sub 101, 102, etc. Could be anything. And sequences could go on forever, or they could be finite. Okay, so consider the sequence of prime numbers in ascending order, 2, 3, 5, 7, 11. This is very definitely a set of ordered numbers. I hope this makes sense. Yes. Sometimes it's also used with function notation. A of 1 equals 2, A of 2 equals 3. Normally we say the A sub because it's a subscript. Would A of 5.2 make any sense? No, not when we're talking about sequences. When you're talking about sequences, that number has to be what kind of a number?
It's not whole, it's like a whole,
Natural numbers, also known as the counting numbers. But actually, we sometimes use 0, A sub 0 as a first term, because that's like the not, the beginning place. Yeah, so in this example, A sub n represents the nth prime number, and the set A sub n represents the entire set of prime numbers. To write out the first terms of the sequence, what effect does this have? Oh, anyway, let's work out these numbers. So A sub 1, the very first one. Just talk it out with your partner. What is A sub 1? Do you already know how to do that?
Yeah.
And can you show me what you got once you get a number? You might need 2 hands. Yeah, nice. Exactly. Yeah, so I'm seeing 1/2. Yeah, at 1/2. And we get that just by plugging in the 1. So if you're doing all the work, it would be -1 to the 1 plus 1 times 2 times 1 minus 1 over 2 to the first power. So of course that does equal 1/2 when you work it all out. Can you do the next 4? Check the paper. Make sure you're getting the same thing for A sub 2 as you go. Make sure you're getting the same thing. Okay, so A sub 2, what'd you get?
-3/4.
-3/4, is that right? Okay, A sub 3,
5/8.
5/8. At this point, did you stop plugging it in?
No,
Could we?
probably.
So the next one is going to be -7/16, and then A sub 5. After how many do you think you could just stop plugging it in?
3.
Get them. 3 is probably a good minimum to have to jump off to just see that pattern. You don't have to list them like this. You can list them in a set. We could do 1/2, -3/4, 5/8, -7/16, 9/32, and that would be complete set. That would be listed in the first 5, and that's fine. Remember, it's just a list of numbers. Just ask for the first 5. That is it. Why is the top going up by 2? What makes it do that?
it's being multiplied by.
We see that 2n. So if it's instead of 2n, it would have been 3n, the top would be going up by 3. So if we're going, if it said 7n, it would be going up by 7. So of course, the bottom is changing as a multiple of 2. Those look familiar from exponential, huh? Right, little echoes of that unit. What is that -1 to the n plus 1 do? Yes, Race?
Which is the term positive to negative.
Exactly. Are we good with that? So once you have the first one, does it make sense that if the first one's right, you don't have to keep plugging it into that portion, it's just going to switch back and forth. It's called an alternator. So this is an alternator. And this is an alternating sequence. Just some basic vocabulary. Pretty intuitive so far, isn't it? Just putting pieces where they belong, hopefully. Okay. We'll say a sequence is defined recursively when subsequent terms are calculated by calling upon previous term of the sequence. Have you studied recursive things, any of you? Recursivity. In what class would you have seen this possibly? Honors algebra 2. Okay, possibly. Comp sci, right? Any of you seen this in comp sci? Well, if you haven't seen it before, welcome. This is recursive sequences. This contrasts the sequence in example 1, which was defined explicitly. Explicitly means if you want the 100th term, you just plug in 100. Recursive is a little bit different. So here's one example, right? The first 5 terms of the sequence defined recursively by b sub 1 equals 1 and b sub n equals n times. Oh my gosh. When you see this, I want you to think. Any idea what words I want you to think instead of b sub n minus 1? Previous term. Okay, so in other words, I know that b sub 1 is equal to 1. That's given information. B sub 2. Do you see what that's going to be equal to? It is 2, right? It matches times the previous term, which is 1, which is equal to 2. B sub 3. Check to make sure your neighbor's following along here. Show me the answer that you got for B sub 3. Seeing sixes, yeah. This is just 3 times the previous term. And I write the previous term as 3 times 2 times 1. Then write out the rest. B sub 4 and B sub 5. So you got B sub 4? It is 24. I'm going to write it as 4 times the previous term, which is 3 times 2 times 1. And of course, B5 is 5 times the previous term. I trust you to be able to do that multiplication to get those numbers. But I'm doing this for a reason, because it's asking us what sequence this is, and you recognize. Did you already check in with your neighbor? What is this? What are we talking about here? What's the word?
Factorial.
Factorial, right? This factorial sequence. So although the sequence can be defined recursively, we can also define this explicitly. By saying that B sub n equals n factorial. So very often sequences can be defined both ways. Moving on. Okay, this one's a little bit tricky. And you can know to think about it. You know, a sub 1 is equal to 10. Discuss with your partner what a sub 2 is equal to.
I think so, yeah. It's equals.
So just one or two.
No, could be, I think it's like A of N. Another thing,
Can you show me this answer?
that would,
What's you saying?
This seems.
Just
very dumb.
in the
It's,
little.
It'd be two.
unless
So-
you want.
Can you show me? I saw one person, 2 people.
Oh.
Nice. Okay, you have 2 choices. Very specific. Now. We can see to get A2, it's based on the previous term, and the previous term is it odd or is it even? No, it's not talking about this number. It's not saying if n minus 1 is odd or n minus 1 is even. It's if the term before is even, if the term before is odd, that distinguishes whether or not you're at which one of these you're going for. So we are using this one for a sub 2. Which is why the answer is 5. I'll give you a moment to continue. First 8 terms.
Because once you get four, right here, then it goes to 2 and then 1, and then from 1 it's back.
It's a good.
Cause like,
Yeah.
It's the.
once it gets 1,
Doesn't see this.
I wonder like what we could start with, or make it like this, or we could go later. Like if it's like this.
Yes, this is like a famous problem, right?
Yeah.
Like you'll repeat 4, 2, 1, no matter what number you put in.
Oh, I think you're right.
Yeah.
Something like that. Not, maybe not exactly that.
Oh, no.
Okay, for a sub 3, what do I have to do? Or you do that 5? You have to plug into the odd one, which makes it go to 16. So A4 is equal to 8. A5 is equal to 4. A6 to A7. A8. 4. Should I continue?
Just gonna.
2, 1.
Yeah, there we go. 4, 2. So if we were to write this as a set, it would be what? 10, 5, 16, 8, 4, 2, 1. Should I just put like a line over something? Or the 4, 2, 1? Although I would understand if you did that,
Oh, I get it.
that bar above only applies to decimals. So if you want to write it out such that the user knows or the reader knows what's going on, I recommend doing it once, twice, and maybe 3 times so the pattern is established. And then go on like that. Maybe there's a convention. Oh, I don't know. And commas there, don't I? 4, 2, 1. Sorry. Maybe there's a convention that that would indicate a repetition for just a little piece of a set, but I don't know what it is. So that's what I offer to you. Write down an explicit formula for the nth term of a sequence a sub n suggested by each of the following patterns. In other words, if I want a sub 5, I want an expression that will just give me that 5th term. I'll give you a moment to work on that. Did you get it? Yeah, Eva?
And minus one. Plus three.
Are we good with this? This is perfect, except for one thing. This is recursive, and recursive is great, but to be
Oh,
complete,
it's.
yes, that's for explicit, explicit. But when you have recursive, and I'm gonna put this as recursive, and I appreciate this. Recursive needs what? It needs a first term, it needs a place to start. So we would say that a sub 1 is equal to 7, and then n is greater than or equal to 2. If you want to be super thorough, you could say that n is an element of the natural numbers. I think I would never require something like that on test or takeoff for not including a subset like that. But that is recursive. But how about explicit? Did anyone get explicit? Cyrus?
A sub n equals 3n plus 4
3n plus. How did you know it's 3n?
because it's incrementing by 3. And then it starts at 7, so you just add 4 to start it.
Are we good with that? Yeah, when it's linear like that, just give that common difference times n and adjust it appropriately so that it's starting at the right place. And there are other versions, and I will give you later on in this unit a more direct way to get there, just in case there's a problem. But that's a sure way to get there. So does this work? Like if you plug in a 5, does it give us what we want? Of course. Thank you. The next one. Not so easy. Let's see if you can find the pattern.
Which how does it? I think it's adding like another two, like here at 4, here at 6, here at 8, basically 2. So like I guess it could be like not something. Or if it's even like
Any luck? Hope we're not finding the difference between them. That's not going to be helpful. Piper, do you have an idea here?
n is equal to 1 over n squared plus n.
Whoa, how do you get n squared plus n? Giant stuff.
Yeah.
Yes. Wait, does that work? 1 over n squared plus n, is that going to work? Like if it's like in a 2, does that get us the a sub 2? If we plug in a 4, does that get us a sub 4?
Oh, no.
Nicely done. We don't all have natural genius like that though. So how do we break it down so this is within our reach? Because there has to be some sort of pattern. Cyrus, do you have any idea?
Well, I feel like I remember, well, like ignoring the fact like that it's over 1, like the bottom, the denominators. If you like the first difference, it's like 4, 6, 8, and then like the second difference between those is like a constant 2.
Okay,
So I remember like if you get like a constant like second difference like that, then it's an n squared.
nice.
But
So you recognize the bottom is quadratic based on
Yeah.
what you learned in the previous math class. So that's not familiar what he just talked about to anybody? Yeah, not a lot of math classes do that, but I'm glad that you remember that. Which teacher did you do that with?
Mr. Chang in algebra 2.
Okay, impressive. Nice. I'm gonna show you a different way, unless, can someone else see a pattern here? I'm gonna bring back something that you did in elementary school called multiplication. And I'm gonna break up that 2 and rewrite it as 1/1 times 2. The 6 I'm gonna break up as
Times three.
2 times 3. I'll let you continue with that. Yeah, you just. Are you seeing it?
Yeah,
Yeah, Josh, what do you see?
I think it's 1/1 plus n times 2 times n.
1 plus n times 2 times n.
Plus,
Plus
plus n.
2 plus n. Okay, this is interesting. But if I plug in a 1 here, I'm not sure I get a sub 1.
No, you do not. Is it 0 and 1, not 1 and 2? But is that also just the thing from above?
Let's finish this. So 12 we think about as 3 times 4.
Okay.
You're right, you're hot on the track. You're right there. Addison, can you help us out with this?
Yeah.
I think that's what you do. Does that work? Is that exactly what Piper said 5 years ago?
Yes.
It's the same thing. I don't know how you got the n squared plus 1, but that is impressive. Once you realize it's quadratic, it's a matter of, I guess, making it happen. Well done. Yeah, so sometimes you have to kind of dig into numbers a little bit to see if you can find a pattern. Or just rack your brain trying to figure it out. Oh, yes. Okay, look at what's coming right now. Have you seen this before?
God, summation.
Summation, yeah. I'll give you a minute to just look forward to this. When you talking at 12:20.
I mean, that now for the first 4 terms. Based on what it's, Wendy's. Wait, did we do buses on purpose? Okay. Okay, that's a little bit awkwardly shaped, but
Are there any lefties in this class?
good.
Hey. That is funny. Who needs those lefties? I'm a lefty.
It's like the world not built for lefties, like notebooks and stuff.
It's not built for lefties, yeah. Thank you. Thank you for your sympathy.
Yeah.
Fuck. Scissors too. Have you guys tried to cut with your left hand?
No. Wait, are they actually?
work?
They're not ergonomic.
They don't like squeeze the right way.
Are we done?
Oh,
We,
you
you
can go.
take some.
Is that-
So. This is for taking.
Thanks. Just in time. Look at that timeliness. I appreciate that.
Oh,
Sorry.
no, I was sure.
The last bit.
Okay, let's finish this up, shall we? What letter is that?
Sigma.
It is a sigma, it comes from the Greek alphabet. And I don't know what the Greek word is for some, but it definitely starts with a sigma. So when you see a sigma, that means we're going to be adding things together. So I know it's intimidating, especially the first time you see it, but really it's just about knowing where pieces go and putting them into the right place. So this k equals 1, this means this is the starting. Or starting, I'll say starting point. N. This is the ending point. And point is a little bit vague right there because we're not dealing with points, but you'll see what I mean in a minute. So the first term is a sub 1. Why are we starting with a sub 1? This is telling us that's where we start. This would have been a k equals 2 at the bottom. Then we would have begun this sequence with a sub 2. That's all it means. And we add. Why are we adding? It's because it's a sigma. It's telling us to add a bunch of stuff together. Do I go forever?
No.
No, I go all the way up until a sub n. If that would have been a 10 up there, then we would just add it up to a sub 10. Yes.
So K is the subscript, not the like actual.
Yeah.
value.
Good point. Yeah, k is this subscript for here. Or what k is just the value in this expression here. And these have to match this. K equals to the bottom has to match this. And this would have been a sub n. We would have started from n equals 1. So let's try an example. So this first one, would you please show me how many terms I'm going to be adding together here? Think about it. Think about it. Check around you, make sure everyone's holding up the same number of terms.
Oh, it might be one.
I think we did 8 because. I think all my friends. So there would be.
Is it-
It is
This would be
4 terms, right? Because first you plug in a
Ah,
5, 6, 7, and 8. So what do you plug the 5 into? Well,
it's-
3 times 5 plus 1 into the k. I'm not gonna add these together and I'm not even gonna do any real work. It says write out each sum, do not attempt to add the terms. The second one is gonna be 3 times 6. 3 times plus 1 plus 3 times 7 plus 1 plus 3 times 8 plus 1. And that's it. I'm done with that problem. Would you be able to continue on your own if I asked you to?
Mhm.
I trust that that's something you can very easily do. And that's not the whole part of the point of this exercise. This is just making sure we could translate it from sigma notation into summation notation or summation into a sum. Okay, so that was A. Can you please do B? Oh, this begs the question right off the bat.
The exclamation mark go to just the K or the whole thing?
It just goes to the K point. Of course, exclamation point mark. I forgot to mention that earlier. I did talk about, but that does mean factorial. Would you please show me what 0 factorial is equal to? If you know from another class, please show me what 0 factorial is equal to. It is counterintuitively equal to 1. I know it seems like 0, but it's 1. Why? I'll explain that more when we're talking about counting.
Say or
Oh, no, at the end of the unit. Okay, so with that in mind, go ahead and go and do B and C. How many terms does B have? How many terms? Okay. When you finish B, check it with your neighbor. Remember, you don't have to add them together, just show me an expression. Yeah. Okay, so here we start with 1, is that right? 1, then minus 1, is that, are we good with that? Then plus 2 minus 3 factorial plus 4 factorial minus 5 factorial plus 6 factorial. Are we good? Interestingly enough, it seems like we could have started, instead of from k equals 0, we could have got the same thing by starting with k equals 2. Does that make sense? That's the exact same thing since those first two terms cancel out. So two different summation notations that are equivalent. And I trust you to be able to do this. Do we have to plug in to that exponent every single time? Once you do the first one, understand it's always going to be alternating. So make sure to just do the first one correctly. Any questions? Okay, I'll let you do C. Maybe some of you already finished. How many terms are here? 4.
you just want us to put it in for X and then leave it?
Well, for K. Yeah, it's just like we did for the B.
So I didn't do that.
I mean, when you say leave it, you mean not do the math?
Yeah.
Yeah. I'll call on someone for this in just a moment. You ready? Can you tell us what you got for C? So you got 7/2. Okay.
Oh, and then I got,
12/5. Okay. I'm sorry, I'm having a hard time hearing you. That was 10. Okay. Okay. Anything else? Why'd you stop? Nice. Are we good? Could you add these together?
Mhm.
Does the thought of doing so really annoy you? Yeah, I agree, Dwight, too. Yeah, let's leave it just like that. The rest I can handle. That one, no. Okay, here we go. We're going the other way. Express each sum using two different summation notations. Go for it. Maybe you already did this. Once you have one summation notation, check to make sure your neighbor got the same thing you did.
Do you think I would say?
I think it's in this alternating.
Two couple.
Are you ready? For at least one of them? Eva, can you tell us what you did?
One I got was, I don't know, with the K equals 2. on there.
You start with K equals 2? Ah, interesting. Okay.
Oh, wait. No.
No, it works.
Oh, it does? Oh, it
Whatever
could
you
just
want.
be for different.
I couldn't care less. With
Oh,
mine.
I think I wrote it. So I think it'd be for the one I did, it'd be K equals 1.
Okay, equals 1. Okay.
Um, And then in front, and then at the top, 15. Oh, wait, no, I think it.
Let's talk about this part, like right here. What do you put there?
I think, I think I did it wrong.
Uh-oh. I noticed that they're all fractions.
Yes. So it'd be, I think it. Oh, wait, I think. I think you do K equals 1 and then at the top 15, or no, 14. And then, okay, yeah, and then K over K plus 1.
Something just clicked in place. What happened?
I think I was just looking at it wrong, but it makes sense.
Are we good with this? That's impressive thinking under pressure like that. Very nicely done. Okay, and again, it doesn't matter. You could use K, you could use N. Sometimes you're gonna see I. Like when you get to calculus, which for me is really uncomfortable. I recommend not using I or any variable and any vowel. Or the well, whatever you want. I won't judge. I'm okay. I need another one. Who'd like to tell us another sigma notation expression? Yes, Hyper.
15 of it.
With 15 of it. Okay.
Zero.
Equals 0. Okay.
And then each one plus the other two.
1 plus K over 2 plus K. Cool.
If on the test, you said use two.
Wait, are we okay with this?
No, because we get to 15, you'll be carried up.
Well, let's see the first term. First term is right. Second term, like in a 1.
Oh,
That goes up to 13. So that gives us the last one. Are we good? Beautiful. Yes, Josh?
If on the test, you asked for 2 and we did these 2, is that okay?
Absolutely. Yeah, these two are great. How many different possibilities are there?
Infinite.
Infinitely many. Yes, Addison.
So when you're finding multiple solutions, is the difference between the ending number and the beginning number going to be equal every single time?
That's a good question. Will that difference be the same every time? It's For that same expression?
The amount of variables, yeah.
Perfect, yeah. No, that's good. What I wouldn't accept if you were if I were asked for two different ones and you did something like this. And equals 1 up to 14, right? If you just did a different variable. That doesn't count as a separate one, that's just a different color. Kinda. Okay, I'll give you a chance to do B. Did you already do B? I feel like they already gave the answer away though. Didn't?
Yeah, they did last.
That's no fun.
B plus one.
Oh,
You can always.
I don't wanna think about that, but.
Can I call on someone in about 15 seconds?
Yeah.
Oh, wait, did I do it wrong? Is this not giving it away? Oh, yeah, it is 12. Oh, wait, I did do it right. Okay, and I did. Do it right. Okay, what? Just the last one.
Okay.
I told you everything.
Grace, did you get something?
I said that. K equals to 1. Then the top is 11.
Okay.
And so. K plus 1 times 2/3.
Times 2/3. Times K?
Oh, that's the power.
Oh, to the K power, or the power of K. Are we good with that? Is this true? That's one, yeah, they gave it away. What's another one? Yeah, Eva, for 300.
You could do K equals 1 and then go to 12.
1 to 12, okay.
-1 to the. 2/3 times 2/3 to the K. This one, please.
Oh, 2/3 times 2/3 to,
Oh, sorry, no, 2/3 times 2/3 to the K.
Doesn't the difference always have to be?
Okay.
Yeah, it could be two. K is.
Oh.
didn't
Okay,
we start at K equals 2?
oh, yes, sorry, yeah.
Are we good with that? Nice. Yeah, either one of these is fine. I think these are the most sane. It would be strange to start with K equals 50, but you could. If you like that. Yeah, I think that's all I have for this, isn't it? Is that the end of this? What do you think about the 6 notation? It's kind of cute, kind of like a little puppy, like, oh, what is your little pup? No, not that cute, but not dangerous. Did anyone take the ACT recently? Would this have helped?
Yeah.
Possibly.
Oh, like, is it-
I'm late.
And you can just use the answers. in-
Yeah, if a person.
What?
Wait, did you pick it? Okay.
Yeah.
Fed.